can be found starting on page 7 of your handout. Okay? Now, I'm sure you all perfectly remember this slide. We actually did look at this slide, or a similar one, in 212. Because at that time, at the back of the knee is a good example. You have lots of muscle, and you have 3 colored tubes: yellow, red, and gray, or blue. Okay? That's what we have. All right? We have lots of nice muscle there and up there. We're certainly not going to go back and visit that. But in 212, we also looked at this. Right there. That's the yellow tube. On Baldy, that's a nerve. And again, we're not going to go back there and enjoy the finer points of a nerve. What we're interested in today are the other 2 tubes, the red and gray, which are artery and vein. And that's these 2. Basically, there's another vein right there, the smaller one. Okay? So, we're going to focus on these. And we have an artery, and we have a vein. So, first, let's get a little more magnification and a much better focus. Okay. An artery or a vein are tubes. So we have a wall, and that wall has different features that you will be required to possibly identify on Lab 1, which, since we're talking about Lab 1, it just happens to be next week for your viewing enjoyment. Okay? Next Thursday. Not 2 days, 9 days. All right, so here we go. This is an artery. This one right here. That's a vein. There's a smaller version of the vein right there. But we'll focus first on this. All right. The wall, as mentioned, has features. And the first thing to know is that the wall has 3 layers. They're called tunics. So you have tunica intima, tunica media, and tunica externa or adventitia. Okay? So we're talking about this. Here, the wall. This is the lumen. All that is coagulated blood. Those little dots are red blood cells. They should not ask you anything about that. Okay? Just so you know. Okay? So, here's the wall. And the innermost tunic, tunics are considered major layers or general layers. Okay? So tunica intima or tunica media, same thing, has 2 parts to it. Okay? It has something very obvious. Here we go. Internal elastic membrane. Dark curving line looks like someone did a bad job tracing the inside of a vessel with a marker. We're talking about this dark line. Very, very obvious. This is the internal elastic membrane. Okay, and we could be completely bored and go all the way around. But that's not what's in contact with the lumen. There's an actual layer inside of that. It's called simple squamous epithelium. Simple squamous epithelium. Looks like junk inside the internal elastic membrane. You remember, simple squamous. What's that mean? Single layer, very flat cells, right? You recall from 212? And here it is. See this stuff right there? You can see it here and here, a little bit there. There's some up here. There's a little bit hanging out. Okay? This is the simple squamous epithelium. You can see it very nicely right here. Sometimes it seems like it disappears. Sometimes it's not even obvious at all. But that's basically what it is. It's a single layer of flat cells that actually is inside the internal elastic membrane. Together, simple squamous epithelium plus internal elastic membrane equals tunica intima. Okay? So each of these would be considered a specific layer or sublayer, and then the tunica intima would be the major layer or general layer. Okay? They use that kind of terminology on the exam, so you have to be familiar with it. Major or general, same thing, versus sublayer or specific layer. Okay? All right. Then you have a middle layer. It's called tunica media. Middle. Okay? It has two parts also. Okay? One part is something over here is better. So immediately outside of internal elastic membrane, so starting right here and going all the way to there, this is tunica media. It has two parts also. It has this nice thick layer, that's smooth muscle. All this sort of tannish layer is a layer of smooth muscle. Okay? In addition, immediately at the outside edge of the smooth muscle, the very first dark line, just the very first dark line, that's the external elastic membrane. Not all these dark dashes, dots, etc. Just this line. Okay? That's the external elastic membrane. So, tunica media equals smooth muscle layer plus external elastic membrane. We okay? And then outside of that, you have all these dash, dark, these are all elastic fibers, okay? Plus all this out here, connective tissue. Here. There. So all this up here is the outermost tunica, tunica externa, or tunica adventitia is what it's called. It doesn't have specific sublayers, just one general layer. So it starts immediately right here and goes out. Okay. Now, within tunica externa or adventitia, because of the fact these vessels are relatively large, and you have lots and lots of cells all over the place here, They do not all get their nutrients and oxygen, etc., from red blood cells in the lumen. They do not. And so a large vessel such as this actually has little vessels that go to it. They're called, as your handout shows you, vasa vasorum, vessels of the vessels. Okay? Tiny little tubes that help to bring oxygen, nutrients, etc., to the cells of the wall. And you can see those. And I stopped here because you have a nice little cluster. And they look like little tubes. Here. Here's several over here. There. And there. Again, has to have a lumen. There's even a tiny little one right there. Okay? Here's one right here. Okay? This is actually a small-ish artery, so that really wouldn't classify as a vasa vasorum. Vasa vasorum doesn't have all the layers. It basically only has the inner layer, the simple squamous epithelial layer. Okay, so here's probably a couple too, but it's kind of fuzzy. But these definitely. Here, there, these little clump right there. These are all vasa vasorum. Okay? You can find them closer in. If you look around, you can find them even in closer. But since these are easily seen, and they serve to identify. This happens to be one of their faves. Okay, so please make sure you can identify vasa vasorum. There's a strong likelihood they will make a brief but dynamic appearance on lab 1. Okay? I'm going to point out a couple of other faves. Okay? So, all right. Those are the things you need for an artery. Questions? Pretty straightforward. The main things to look for an artery, especially the internal elastic membrane, typically very, very prominent, and an external elastic membrane, also a thick, dense tunica media, the smooth muscle layer. There's a reason for this. Arteries have to withstand much higher pressures than veins. We'll talk all about that in lecture in chapter whatever. It's coming up. Okay? As to why you have this design. Again, the old cliche, which does work. Structure, function, they follow each other. So here's another example of that. Okay? All right. If you like that artery, we'll go to the vein. We good? All right. Vein was, if you remember, right next to it. Here he is. Veins can typically be larger. Arteries are very often, most often, roundish. Veins can have all kinds of wacky shapes. This one's a little bit elongated. They can even come in a little bit stranger shapes. All right, so let's look at a wall of a vein. A large vein, such as this, has exactly the same layers as an artery. So it's got the 3 layers, especially if I focus this better. It has tunica intima, tunica media, and tunica adventitia or externa. Okay? However, a few things you may notice aren't here. What's the most obvious? There's no what?
The
internal elastic membrane. The tunica intima in a vein is nothing but the simple squamous epithelium. That looks like it's all beat up. See this little darker layer kind of right at the edge? This is the tunica intima, which is the same as the simple squamous epithelium in a vein because there is no internal elastic membrane in a vein. Again, it doesn't have to withstand the same pressures as the arteries do. You then have, you have lumen. Again, you have coagulated blood, all that stuff there. Then you have a tunica media. It's obviously not as dense as the tunica, as the smooth muscle layer in the artery was. Okay. You can see elastic fibers here and there, even in the smooth muscle layer. And another thing that's absent, there's no external elastic membrane. So, the tunica media consists only of the smooth muscle layer. You then have the adventitia, which looks very much like the adventitia that you see in the artery. And you can also find, we just roam around. See him? What do you see? Vasa vessel. There's a real little one. Here's a little one. Okay, any others? Here's a somewhat bigger one. Now, that's not a vasa vasorum, again, because you can see a nice internal elastic membrane on that. Okay, so that's a small artery. Again, make certain you can identify a vasa vasorum. It's very likely to be there. Right? Any questions on artery or vein? The layers. Again, major or general, and specific or sublayer. Okay? They will use those terms. They often will just give you a picture. Identify this overall structure. Artery. Okay? Then they may get specific, you know. Identify this tan band. Smooth muscle. That layer is part of what major layer?
Tunica media.
Tunica media. Okay? Those are the types of questions you will probably encounter. See how they do it? Okay? First time. Okay? Now, if, they should not, but if point to that nonsense, I'm going to change the question. For, if they ask you, what's this? The lumen. I've never given a test where they ask lumen. That's a complete waste of the question, in my humble opinion. Okay? We want other stuff. We've got a lot of other stuff we can ask. So, it is the lumen, but pretty obvious. We've got much more interesting things. Okay? All right. We okay with artery vein? All right. The next one. Now we have three structures. The second one, go to page 8. Who's first? Spleen. Alright, let's get a spleen. Who's got a spleen? Well, hopefully we all have a spleen. Alright. There's a nice spleen, or part of one. There's a good one. Okay. Alright. Where's your spleen? On the left side, right over here. You got a one, not no right side, just one over here. It's kind of flattish, a little bit elongated. Okay, so it has a basic structure. It is another structure that has a capsule. Okay, remember we've encountered capsule now. Okay, it's this outer connective tissue covering that kind of surrounds the entire organ, and it's typically stained pinkish. Again, connective tissue type, and if we were completely bored, we could show it going all the way around. Okay? All right, so that's a capsule. And the spleen has a particular shape. Part of that shape is brought about by the fact that there's a scaffold throughout the organ. And that scaffold is basically an extension of the capsule. And all the pieces of the scaffold are called trabeculae. And they ultimately all connect to the capsule. And so I stopped here because you have a great example of a trabecula that actually shows you its connection to the capsule. Even all these are trabeculae, and they ultimately connect to the capsule. But remember, we have a two-dimensional slice of a three-dimensional structure. So this might go in, or it might come out and then back up, etc., that kind of thing. But they all do. If we had nice serial sections, we could follow each and every trabecula that would eventually connect to the capsule. Okay, it's the scaffolding, connective tissue. All right. Then we have some other obvious features. Now, these are brought about because your spleen does two basic things for you. It's part of your defense system, your immune system, and it also performs a major function by removing all those worn out red blood cells. That leads to the two basic divisions or parts that you see. Okay? In the one case, the part that's part of your defense immune system, these are called splenic nodules, splenic corpuscles, or just white pulp. Even though they're not white at all when they're stained. Go figure, as they say. Okay? But anyway, we're talking about these kind of bluish round structures that you see. There's a lot of them. There's one, there's one. We got a little more piece of one, there, 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 there. So all throughout the spleen, you have splenic corpuscles. Or you can call them white pulp. It's there. Okay? Whatever. But again, just remember, they're not white, obviously. They're stained blue. And they're stained blue because they really consist of a gazillion lymphocytes, a type of white blood cell. All those blue dots are the nuclei of lymphocytes. See them all. This is just one. There's a gazillion. Okay? So many of your lymphocytes are just hanging out in your spleen. What are they doing there? Chilling, waiting. Okay? We'll explain in another chapter what they're waiting for. Okay? So I like to say. They're waiting for the antigen of their dreams. Okay? We'll get to all that. All right? Okay. So, these splenic corpuscles have lymphocytes packed in there. Okay? Now, in addition, there's another feature. All right, well, there he is. That's a good example. In addition, these splenic corpuscles have a structure called a central artery. Pink circles inside nodules, which are specific structures. There may be more than one, and not always central. Very rarely central, even though the name says central artery. So here it is. Here's this splenic corpuscle. And right here, at the outer edge, in this particular case, is a central artery. Right? Whoops. That's not going to help much. Features. It must have a noticeable, obvious lumen. It's a small artery. It may have little dots in there. Those would be red blood cells. Okay? It's not just a trabecula. Okay? Again, it must have an obvious little lumen. And it may be closer to the center, it may not. As long as it's within the obvious splenic nodule, it's a central artery. There may be more than one. A couple semesters ago, when I was teaching this course, some student found 5 in one splenic nodule. That's a little high. Usually you might find 2. Or on occasion 3. But in that one case, we saw 5. Okay? You may even come across one where you don't see an obvious one. Okay? Right, but those are called central arteries. Okay, take that picture. You all have photographic memories, right? Yes, of course. Okay, so take that little picture. Okay, file it away because. We'll tell you because in a minute. All right, now, back to the last part. We told you your spleen did 2 things. So this is the defense part. These splenic nodules, there he is. Right there, central artery. It's just on the outer edge in this case. And again, it is not a trabecula. All right. The other function of your spleen, to remove dead, dying, and worn out red blood cells. That's a function of the other areas. They're called red pulp. And that's any area that does not have an obvious nodule. So down here, up in here, over here, all these areas are the red pulp. All the rest, let me even go to there. Okay? We don't want that. That's not red pulp. You have some all in here. Now, remember, you got a lot of trabeculae, but in between that, so up in here, okay, you got some over down here. This is all red pulp. got white pulp or splenic nodules, and you have areas in between red pulp. Questions? Yes.
You said the central artery has a continuous what? And this is for
Lumen. A hole in the middle. It's a little tube. Okay? So you can see the areas of red pulp in between. I just moved around a little bit. But there are lots of areas of red pulp. Everything kind of in between the round bluish areas is considered red pulp. Questions on spleen? We good? All right. Now, let me skip one, and then we'll come back to the one I've skipped. All right, we're going to go to the thymus. You have to turn the page to go to the thymus. All right? Okay, here's thymus. Again, just to remind you, where's your thymus hiding? Who remembers? Behind your sternum. Bring it back down in there. Okay? It has a capsule. Okay? A capsule on the outside. Capsules often show you a lot of adipose. Sometimes it accumulates there. And the capsule has extensions, trabeculae. These are very obvious in the thymus. All these white divisions are all trabeculae. They're much more obvious. But they're the same basic idea. Okay? Trabeculae, or little beams. Again, they provide a scaffolding. It's very similar to, you got them in this room? Yes. We have pillars. Pillars are the scaffolding for a building, right? They hold the thing up. Exactly kind of the same idea. All right? All right. The trabeculae divide the thymus into chunks. Those are called lobules. So here's a chunk. There's another chunk. There's another chunk, etc. You can see them. They're obvious. Lobules. Now, one thing about the lobules. What can you see? Very basically. Let's take a lobule. Okay, there's a lobule right there. What's something that's pretty obvious about it?
Dark.
It has lighter and darker parts. There it is. It's easy. It's staring at you. Okay? Those are called cortex and medulla, things we're very familiar with. The outer darker part is called cortex. The typically inner lighter part is called medulla. All right? Very straightforward and easy. The medulla, less dense, lighter. The cortex, more dense, darker. And within the medulla of a lobule, you have a structure you must identify. Okay, let me take within the lighter part, you can actually even see it's lighter. Because up here, you can see it's darker. So this area is medulla. Within the medulla, you have thymic corpuscles. Lighter or darker stained circular structures within the medulla that will not be filled with dots, like the rest of the medulla. We're talking about this type of structure. Circular, layers of cells in a circular fashion. Most often, you do not see what looks like a lumen. These are not arteries. They don't have a lumen, although that one sort of looks like it does. Okay? Let's get another one. Thymic corpuscles. One of their very faves, so to speak, is to give you both a central artery and a thymic corpuscle and have you identify it. This, since I've been standing here a few gazillion years, presents a challenge to many students. Please come to Lab 1 being able to identify thymic corpuscle versus central artery. The likelihood is very high. They will both appear and ask you for them. Okay? Very high. In fact, I don't remember a 213 exam, first exam, where they didn't have both of them on there. There may have been, but I don't recall. Okay? So, please make sure you can identify one versus the other. Any questions on thymus? The other parts are pretty straightforward. Okay? Okay. And last, let's go back to the previous page, page 8, and deal with the one we did not deal with. All right. That one in particular is called a lymph node. And you find them. There are many lymph nodes. Middle of page 8, lymph node. Now, here's the exception that proves the rule. Okay? We've now encountered several structures with a capsule, right? That's typically the outermost structure around an organ. This is not the case for lymph nodes. There is tissue outside of the capsule. It has a capsule, but there's tissue outside of that, and that's called a pericapsular tissue. Mostly adipose, area found outside of the capsule. Okay? So we're talking about, this is not the world's premier slide. Still has a capsule. It's in the same place, hugging the organ. But there's all this material outside of that. That's the pericapsular tissue, only found in lymph nodes. And there are several features found in the pericapsular tissue. Now, lymph nodes, we haven't gotten to this yet, but basically we all have a completely separate set of tubing besides your circulatory system. It's called your lymphatic system. And it's a whole set of tubes, not arteries or veins, another set. And those, we'll get into all this in lecture, but those drain your tissues of some of the fluid, and it goes through this tubing, and then it goes through mostly lymph nodes. And they're looking for anything that's not you, in simple terms. We'll get to the gory details. But basically, they're looking for foreign antigens that might be in your body. And they mainly go into lymph nodes, the fluid, and then back out. Okay? And so they use lymphatic vessels to go in and come out of lymph nodes. You get a whole bunch of lymph nodes all over the place. You have certain concentrations in certain areas. We'll show you that. But basically, the lymph vessels are found in the pericapsular tissue. The ones that are going to bring in and then take out. They look similar to veins. So you have these vessels, they're called lymphatic vessels. They're found in the pericapsular tissue. And they have a unique feature. Because your lymphatic system doesn't have a heart that is a pump, it actually will show you how it flows slowly. But in these vessels, they have valves, like are found in certain veins in certain parts of your body. That prevents the fluid from going backwards. And so you have pericapsular tissue, lymphatic vessels that have valves inside. All right. Here's a lymphatic vessel. Here's another lymphatic vessel. Almost looks like a heart, but it's one vessel. Here it is. Simple wall. Looks like that. And a valve is an inward extension of the wall. And it looks like a little thread. It connects to the wall on each side. So here's the wall. And right there is a connection to this piece in here. That piece right there, which then connects to the wall down here. This is a lymphatic valve. Right in there. It's often V-shaped. You can't tell that very well. But this little thread-like part is a valve inside this lymphatic vessel, which is in the pericapsular tissue. Three things. Pericapsular tissue has lymphatic vessels which have valves. There. Right there. Okay? This is another of their phase. You got three phases: vasa vasorum, thymic corpuscle versus central artery, and lymphatic vessel in pericapsular tissue showing you a valve. You like knowing about faves? It's helpful. There's not an absolute guarantee they're going to be there, but there's a very strong likelihood. Okay? All right. You can see the capsule, since we've blown this up. There's a capsule going along here, this part. And again, all this out here is pericapsular tissue. All right. In addition, there's some other features. Especially blank features. Here we go. Oh, there he goes. Come on. Come on. Don't be shy. Go. All right. In addition, the lymph node has cortex and medulla. Especially cooperate. All little buttons pushed. Good on push. Okay, there it is. All right. Now, they have trabeculae. They're not very obvious in a lymph node. So here's a capsule. You can kind of see right there. Maybe right there. There are trabeculae in the lymph node. Okay? There is cortex and medulla. Over here shows you that better. Okay? Cortex darker, dense stain. Medulla less dense, lighter stain. So this whole part up there, darker stain. This is cortex. This lighter area, that space is in it. This is medulla here. Okay? And in the cortex, you have these structures. These are called lymphatic nodules. Got some here. Okay? There's one up there. Lymphatic nodule. Okay? You can see a bunch over here. There's no central artery in the lymphatic nodules. Okay? And last, I stopped here for a reason. Some term we have not encountered or talked about before is a hilus or hilum. Okay? A hilus or hilum is nothing but an area of organ where large vessels go in and out. So it's like an indentation. Okay? So here's your kidney. We'll find hilus or hilum in a variety of other situations. Okay? So it's just an area, like an indentation, where larger vessels go in and out. You often see a lot of adipose in that area too. Not always, but often. Okay? So this is, see how it's indented there? All right. So we want to find that in our spleen. And we have it. There's a lot of adipose. This area coming in, there's a blood vessel coming in. So this area here would be a hilus or hilum. Either one. Okay? Again, nothing but an area, an indented area that has vessels going in and out. Did I leave anything out? Questions on spleen? Or not spleen, lymph node. All right, that's it for the presentation today. These slides, which we have just reviewed, are found in trays in that corner over there on the window.